This video is for P3, Part 1, AQA. It's about physics in medicine. So X-rays came up last year as a 6-mark question, so this year it could be more about 1 or 2 mark questions. So X-ray is a 2D image it produces, okay? So when you have an X-ray, the black means it's actually absorbed the X-ray, whereas the white means that the bone or the material in front of it has absorbed the X-ray, so it hasn't gone through to the film or the plate. And when it's a grey, that's usually when it's skin or muscle, stuff like that. We don't tend to use the film anymore. We use something called a charge-coupled device, which is a digital device that can then transfer it onto a computer, so you can send X-rays a lot more quicker than you used to be able to. Another form of an X-ray is a CT scan. Now this is a 3D scan, it's a lot more advanced. It can give a 3D image of slices inside the body, so it's a lot better for diagnosing certain things. You wouldn't do it like unnecessarily, because obviously it's giving people ionising radiation, so X-rays. The dangers I've just said, they are ionising, which means it has the ability to knock electrons off your cells. That then can cause mutations and can lead to cancer. Protection-wise, people stand behind lead screens because that will absorb X-ray, or they have things like exposure badges, which will be film, so you can see the change in colour to know how much you've been exposed to. It can actually be used for treatment, radiotherapy. People don't know this much. It's not just gamma that's used for treatment. You can use X-ray, so radiotherapy for cancer. Ultrasound again came up as a 6th marker last year, so it might be more about calculating ultrasound and stuff like that. Ultrasound is sound frequency above 20,000 hertz. They do ask that quite frequently, and its speed increases when it goes through denser material, because obviously speed is sound travels best through a solid. Now when you're calculating ultrasound, it's just the distance times speed. Distance equals speed times time, but the time that you get will be the time it takes for the reflection and then to come back to the detector, so you need to make sure you half the reflection time for the distance, otherwise you'll work it out wrong. Uses are imaging. Everyone knows about pregnancy. You can also do medical ones, things like viewing hearts, the heart cavities and things like this. Non-imaging, because some of that's imaging, they can then say non-imaging uses. Kidney stones, it can break up. Kidney stones are high frequency, causes them to break up. Also it can be used for muscle therapy, so if you damage your muscle tissue. Good things about it, it does not cause cancer, so it's really, really good, which is why we use it obviously on babies, otherwise we wouldn't use it. It can also be used in industry to find flaws in metals. Now, the thing about ultrasounds is when it meets a different density or that it's travelling through, it will reflect back, so it would travel through, hit the floor and travel back. Submarines as well use it to detect how far they are from the bottom of the ocean bed. So just be aware of the different things for that. Light and lenses, okay? So every single year there's one of these on it, okay? So you just have to learn both of them. Last year it was this type of one. They used about 3 marks. The convex ones can be worth up to 4 marks. So if we go through the converging or convex lens first, this is what it looks like, but on a diagram it would be shown like this. So if you had the arrows going round, it would then look like that again. It produces real images which are inverted and sometimes magnified. Obviously this one here isn't. The rules for it are you go along straight to when you meet the centre of the lens, and then you go down through the focal point on the next side. The middle line will go straight through the centre and just carry on straight. This one then go through the focal point on this side. As soon as it hits it will go parallel. And where these meet or cross section, that's where your image is formed, but it will be inverted. Thing about these is that it concentrates it, okay? So as I've got orange juice there, it's concentrated. This one, diverging and concave lenses look like this, but on the diagram they will be drawn like this. So it diverts the light away from the centre point, where that concentrates it, this diverts the light. So what you do for these ones, you only really need 2 lines. The first line will go from the top parallel till it meets the lens. Then you'll put your ruler on here through the focal point until it meets here, and then it will go straight. This should be a dashed line because it's not a real line. It's not a real ray of light. The other one will go directly from the top through the centre. Now where you get the cross section here, that's where you'll get your image formed. So problems with eyesight, it can be short-sighted, okay? The reason for being short-sighted is the eyeball is either too long or the lens is too fat. Okay, so it means by having that, the lines will actually concentrate or cross over before it meets the retina, so that the image will be blurry. If you are long-sighted though, the reason is your eyeball is too short or your lens is too thin. So it will concentrate the light after the retina, so again you'll have a blurry image. The short-sighted one is fixed by a concave lens. So the way I think about it, if your lens is too fat, you need the diet lens, okay? Your lens needs to go on a diet. So you get the concave one because I think it looks like a nice slipped in at the waist. The long-sighted though, too thin, need to put a bit of weight on, fixed by the fat lens is what I think. So it's fixed by the convex lens. They could then relate this to optical fibres and lasers. So you get total internal reflection, usually about 2 marks. Just make sure that from your P1, your I and your R, so your incidence and your reflective angle are the same for each one going around, and that'd be fine. This is used for things like Blu-ray discs, that's why it's lasers, endoscopes, the World Wide Web. The eye usually comes up in some guys. Last year you had to label certain parts of the eye, but you need to make sure you know all of these. Okay, so suspensory ligaments are what hold the lens in place, okay? So they just hold it, they don't do anything else. The lens is obviously the thing that can shorten or lengthen to change the focus. Cornea is on the outside, pupil is just the whole, iris is the colour part of the eye, the thing that looks pretty. The ciliary muscle though are what are attached to the suspensory ligaments. Now when they contract or move, that's what then pulls the ligaments, which then in turn pull the eye. The optic nerve is obviously what travels to the brain to transfer the signals. The retina is the place at the back of the eye where everything concentrates on, and that helps you see properly.